This is planet Earth. As you see many lights surrounding our planet. These lights represent congregation of people in many thousands and thousands of cities across our planet. We have conquered from the bottom of the ocean to the top of the Everest and even beyond into outer space. We are just everywhere. But if you pay attention, there is this thin layer surrounding our planet. This is our atmosphere. This is the only protective shell protecting life in our planet the way as we know it. This is the layer we need to keep and preserve. My name is Nicolas Waldmann. I'm from the Department of Marine Geosciences here at the university. And my mission and my passion for the last 20 years is to try to understand how climate change has impacted the atmosphere through time. As you can see in the video behind me, you see 150 years of climate change, and now slowly, the world is warming up into very dangerous levels. But in fact, we all ask ourselves, where are we heading to? So, if we have a look into time for the last 20,000 years, from the last ice age, we will see that temperatures are constantly rising, even from levels that are far beyond our present. But I raise a serious question. Has planet Earth experienced these high temperatures in the past? So let me surprise you. Let's travel back in time 5 million years into climate Earth of the planet, and we will see that during specific time periods, Earth actually reached high temperatures even beyond those of the present, and even during short periods of times, and even during long time periods. So what basically we need is some kind of a time travel machine in order to go to these warm intervals and understand how climate change shaped them. But what if I tell you actually that we do have a time travel machine? Well, my travel machine, they are the lake sediments. This mud that is deposited at the bottom of the layer, the lakes, and that actually represent every environmental change that happened in the surrounding environment, from natural to anthropogenic to human-induced, and everything is registered in the sediment. Once I go and I drill those lakes and obtain a sediment core in which together, or analyzing it, I can understand the present climate change.
So as an example, let's have a look together at this approach, as I can show you in this video behind me, taken in Lake Chala, which is in Kenya, at the footsteps of the Kilimanjaro mountain. What you can see is that the work takes place during 2 months, 24 hours a day, 7 days a week, and I was on the night shift. Each barrel that goes deep into the lake sediments go older and older in time and deeper into the lake. And with each barrel, we are actually retrieving 3,000 years back in time, and which is equivalent to 6 meters of each barrel. So with that, we went back 250,000 years of climate history in East Equatorial Africa.
But this is only one lake, which is next to Kilimanjaro, which is an amazing setting in the background. But in order to understand the climate of the planet, we need to go to many places to receive a holistic overview of climate change in the world. So for that, my team and I, we received sediments. Sometimes we go, sometimes we obtain them from several places in the planet, starting from St. Paul Island in Alaska to Kiribati, and even to the southern hemisphere. Once all these lake sediments come to the lab, we actually analyze them, the physical, the chemical, and biological properties that together represent in a holistic fashion the environmental conditions that change through time. So instead of panicking from what our future holds, let's work together and learn from the past to understand the present and to have the tools to deal with our future climate change. Thank you very much.